Okay, sorry, I had to go and grab a calculator. So now that I have my TI-89, I found that x, I got two values, but one of them's negative, so you just discard the negative one. And it ends up getting 0.03053 as your x. And now what we're going to do is we are going to plug that in and solve for our second deprotonation. So, I'm sorry, and why did I make this plus? This is a negative. So now, what we're going to do is our second one is going to be, so that's our first one. Our second one is going to be H2ASO4 negative plus water is going to get you H3O plus HASO4 2 minus. Now our original H2ASO4 is now, instead of 0.2 or nothing, is going to be 0.03053. I'm just going to underline that 0. And we're going to go 0, sorry, mistake. H3O is actually going to be starting with 0.03053. And now what you're going to do is you're going to go minus x plus x plus x, 0.03053 minus x, 0.03053 plus x, and x. And now Ka2 is going to be, so here's our Ka2, is going to be 0.03053 plus x times x over 0.03053 minus x equals 1.7 times 10 to the negative 7. And this x should be really small. So it's probably going to end up being x equals 1.7 times 10 to the negative 7th. And part of me doesn't really want to do this, but I'm going to do it. So, try it again. 0.03053 plus x times x divided by 0.03053 minus x, close parentheses, equals 1.7 times 10 to the negative 7th, comma, x, close parentheses. Yeah, and it ends up being 1.69998 times 10 to the negative. Yeah, it's going to be so small. So basically, x is going to be 1.7 times 10 to the negative 7th. And then those would get plugged in here. Believe it or not, this is just going to end up being 0.03053 because it's such a small number. This is still going to be 0.03053. And then this x is now going to be 1.7 times 10 to the... That x is going to be 1.7 times 10 to the negative 7th. Okay. All right. And then we do it one more time with the Ka3. You could tell like your x is basically going to be smaller and smaller and smaller. So now our last one is going to be HASO4 2 minus plus H2O gives you H3O plus ASO4 3 minus. So now we have 1.7 times 10 to the negative 7th. H3O is basically going to be 0.03053. And then that's 0. Minus x plus x plus x. So now you have 1.7 times 10 to the negative 7th minus x. 0.03053 plus x. And then x. And now we have this equaling 5.1 times 10 to the negative 12th equals 0.03053 plus x times x all over 1.7 times 10 to the negative 7 minus x. And we plug it in. There's a lot of work. Okay, F2 solve. Okay. F2 solve. 5.1. Oh. Let me do that the other way. 0.03053 plus x times x divided by 1.7 times 10 to the negative 7th minus x, close parentheses, equals 5.1 times 10 to the negative 12th, comma, x, close parentheses, and it gives us 2.83 times 10 to the negative 17th. So anyways, it does ask you a whole bunch of stuff. So it asks you, it says calculate H plus, calculate OH minus, H3 ASO4. This is all at equilibrium, so this is kind of like the end of the question here. Then I still got room. Okay, and then H2 ASO4 minus HASO4 2 minus and ASO4 3 minus. So let's work backwards. The ASO4 3 minus is going to be that one. Really, really small. 2.83 times 10 to the negative 17th. Like, ridiculously small number. Our H plus is actually going to be pretty easy. It's just right there. So that's going to be 0.03053. Remember, H plus times OH minus is going to give you 1 times 10 to the negative 14th. So to solve for OH, it'd be 1 times 10 to the negative 14th divided by 0.03053, and that gives me 3.27 times 10 to the negative 13th. H3ASO4 would be up here, so it'd be 0.2 minus 0.03053. 3053. So about 0.17. And then H2ASO4 is basically going to be that one, 0.03053. And then HASO4 minus is going to be that minus a ridiculously small number. So that's just going to be 1.7 times 10 to the negative 7th. Okay. So, kind of a ridiculous question, but, you know, you could follow it. It's followable, I guess. I did want to mention one last thing, and then I'll let you go for today. It's like a double period. So the last thing is going to be the relationship between the Ka1s, Ka2s, and Ka3s to Kb of another ion. So you can always come back to the screen if you want to. Hopefully you can see it all. It's decent. It's a good question to go through. I'll give you one that's a little bit easier for practice, but by the way, that was number 108. Okay. And then the last thing I just want to do is, okay, this is kind of like a totally separate question, and Okay. I want to look at H2CO3 for a second. Your Ka1 and Ka2 of H2CO3, this is a pretty weak acid, 4.3 times 10 to the negative 7th, and 5.6 times 10 to the negative 11th. That's carbonic acid. And so, okay, so the next thing you're going to learn tomorrow is the acid-base properties of salts. So salts are generally how you get weak bases. Easy way to get weak bases into solution. And what you do, and you're going to see this in a little bit, but the, of HCO3 minus, by the way, if you're thinking about this, what sort of acid would this be? It's so H2CO3 is a polyprotic acid. What sort of species is this? Amphiprotic, which means it can act as an acid or base depending on what you react it with. So if I said, well, I wanna see the pH or the, let's say, how do I know the Kb of this ion if I'm not given it? Or how would I know the Kb of CO3 minus, which is not amphiprotic? This is just a base. This is just a basic anion. Because it's the conjugate base of a weak acid. So these two things, I can give you some values. So firstly, I could say, well, here's my data on H2CO3. I know those two things. What could I say about HCO3 minus if it acts as an acid? Ooh, I think my washer's almost done. That's exciting. Okay, if it acts as an acid, it's going to take the Ka2, because the Ka1 is going to be this thing dissociating. The 4.3 times 10 to the negative 7th is the one that's going to associate for the H2CO3. If it acts as an acid, I'm going to use Ka2, which is 5.6 times 10 to the negative 11th. However, amphiprotics can also act as bases, and if it acts as a base, I have to go back 1 second and kind of review. A Ka times a Kb equals 1 times 10 to the negative 14th. These must be conjugates of each other. So if HCO3 minus is going to act as a base and I wanted to calculate its Kb, I would have to use the Ka of its conjugate. So the way that I usually do this is I say, all right, Ka times Kb. If I'm looking to use the Kb, I would say HCO3 minus. I have to know the Ka of H2CO3. So then I would say, all right, well, my Ka of H2CO3 is 4.3 times 10 to the negative 7th. I'm trying to find my Kb, and then I would just go 1 times 10 to the negative 14th, and then I could say 4.3, I'm doing this totally backwards, 1 negative 14th divided by 4.3, 7. So that gives me x equals 2.33 times 10 to the negative 8th. So my Kb of HCO3 would be 2.33 times 10 to the negative 8th. So if I just put HCO3 minus in water, what would you guess it might act like? Would it act as an acid or a base? And the answer is act as a base, because the base is a bigger number. So HCO3 if you put it in water, will act as a base because Kb is greater than Ka. This one doesn't matter at all. This one is it can't be an acid. There's no H. So all you have to do is do a Kb. And to calculate the Kb, you'd use this same little trick, Ka times Kb. The CO3 2 minus is going to be my Kb. The Ka is HCO3 minus. And so the Ka of HCO3 minus was just this Ka2, 5.6 times 10 to the negative 11th times x equals 1 times 10 to the negative 14th. And this is actually kind of a stronger weak base. And you get x equals 1.79 times 10 to the negative 4th. So my Kb of this one is, it's actually a fairly hefty number for a weak base. So anyways, I just wanted to show you this in a preface for tomorrow. So, because we're going to talk about salts tomorrow. And remember, salts are just ionic compounds. So that would basically be like if I put a sodium or a potassium with one of these two things, you'd end up like if I did sodium HCO3, it would be a base. And if I did sodium carbonate, it would also be a base, a bit stronger base, because that is a larger number than that one. Okay, so a lot to kind of cover today, but anyways, I will speak to you guys soon. Hang in there with the bad weather, and brighter days ahead.